Okay, so this is the slideshow for triangles. So this is the opening slide. And here you have the table of contents. So from here you can either go to the intro, acute, obtuse, right, isosceles, and equilateral triangles. So let's start with the intro. So there are a few things that separate triangles, but there are a few things that remain definite with all triangles. So all triangles have exactly 3 sides, and within the triangle there are exactly 3 angles. The sums of the lengths of any 2 sides of the triangle must be greater than the last. So when you have any triangle, call this side A, B, C. So let's assume C is the longest side. So that means C has to be less than A plus B. And the sum of all angles of a triangle have to equal 80 degrees. So 3 angles of a triangle, we'll call them X, Y, and Z, have to be equal to, so X plus Y plus Z will always equal 180 degrees. So there are 5 types of triangles. They're acute, obtuse, right, isosceles, and equilateral triangles. So first we'll start with acute triangles. So acute triangles, every interior angle of an acute triangle is less than 90 degrees. So each angle is between 90 and 1 degrees. So that's what separates a right triangle from the others. Not a right, an acute triangle. My mistake. Then you have obtuse triangles. So an obtuse triangle, sorry, this doesn't work quite right because I made this and I don't have the right PowerPoint. So an obtuse triangle has a single angle that is greater than 90 degrees. None of the other angles matter, but in order for it to be obtuse, it has to have an angle that's greater than 90 degrees. So for a right triangle has one angle that is exactly 90 degrees. And there's a bunch of special properties to right triangles. One of them is the Pythagorean theorem. So here's a video about it. But it didn't work because this isn't the right thing. So go back up. So Pythagorean theorem states, so in a right triangle, you have two sides, A and B, and these are adjacent to the right angle. And then you have the hypotenuse, which is opposite the right angle. So, and the Pythagorean theorem states that A squared plus B squared will equal C squared. And this is true for all right triangles. So let's say we know what the length of A and, let's just say A and B are 1. Okay, so 1 squared plus 1 squared equals C squared. So C 2 is equal to C squared. So C is equal to the square root of 2. So we know that's what, or plus or minus root 2. But because you can't have a negative length, C will be equal to just the positive. So C will be equal to root 2. That's all the Pythagorean theorem states. So for an isosceles triangle, there are two sides, at least two sides, that have the same length. So it could look like that, as long as, say, side A and side B have the same length. It doesn't matter if it's acute, obtuse, or right triangle. Any of those triangles can also be an isosceles triangle. So, because it has two sides that are equal, each of theirs opposite, so each of the angles related to that side. So, in this case, it'll be the side opposite the angle. They will have the same, the angles will have the same value. So, let's say angle X and angle Y. So, for every side A that has an angle X, if A is equal to B, then X is equal to Y. And that's true for all isosceles triangles. So that's an example of one. As two sides of identical length and two angles of equal measure. So an equilateral triangle has three sides of equal length and three angles that are all 60 degrees. So, because all three sides are the same length, all the angles have to have the same measure of degrees. So, it's pretty simple that if you have three angles, they have to equal 180 degrees, divided by 3, you get 60 degrees. So if you know any triangle is equilateral, you can determine, you automatically know what the angles are, and you can determine the sides as long as you know one side. So, how do you determine the area and perimeter of a triangle? So, to determine the perimeter, it's the same as for a rectangle. So, you just add up all the sides. So, let's say we have this triangle that has, I think, 2 here, 3, and 4. So its perimeter will be 9, because 2 plus 3 plus 4 equals 9. So for the area of a triangle, it's 1/2 the base times the width. So we have this triangle here. So question is, what is the base and what is the height? So the base is whatever side you're given. So in this case, this will be the base. We'll say it has a length of 10. And the height is the length from the base to its angle. So it'll be that. Nice little right triangle there. So what is this? We'll just say that in this case it's 2. So the area of this will be 2 times 10 divided by 1/2. So 2 times 10 over 2. So let's cancel those out. Get 10. So why do we divide by 2? So this is very similar to, this measurement is the same as if you did a rectangle. So if you have a rectangle, it's one side times another side. The two opposite sides. Two sides of different length. So you wouldn't do 2 times 2 here, because these sides have the same measure. So remember that. So it's these opposite sides. Well, if you separate this triangle like this rectangle like this, you actually get 2 triangles. So that each have a base and a height that are the same as this one rectangle. So it's safe to assume that this triangle has the same, or is half the area as the rectangle here. So if you have a different shape that looks like this, you can separate it into 2 triangles similarly, but it has an area based on the height and a base. So that's why it's 1/2. So these are 2 examples. So in this, for this one, that's 7, 9, and 12 centimeters. It'll have a perimeter of 28 centimeters. For this triangle, you see how they determine the height out here, because the measuring the height doesn't have to be inside the triangle. So it has a height of 10, and a base of 14. Divide all of it by 2. So you get 70 meters squared. That's the area of that triangle. So, in conclusion, there are different kinds of triangles, where the 3 main types are acute, obtuse, and right. And they're all based on their angles. So an acute has 3 angles, all of which are less than 90 degrees. An obtuse triangle has a single angle greater than 90 degrees. And a right triangle has a single angle that is 90 degrees. An isosceles triangle has 2 sides that are the same and 2 angles that are equal. An equilateral triangle, all the angles are equal and all the sides are equal. So, and for measuring triangles, you have the Pythagorean theorem, which only works on right triangles, and you have those properties for area and perimeter.